Good evening, good evening, and good day to you all. And it is a great pleasure to address you all in this Biomimicry conference in 3 consecutive years as well. So I'm Guttila. So today I invite you all to witness that what is agriculture differently, right? So that is where not as an old traditional sector, but as an amazing living system full of intelligence and as well as these innovations, resilience, and inspirations from nature itself. So that is what this presentation we selected amazing. So that is where, but not real focus. That is simply the you can see the amazing, but something deeper. So what we are doing is how nature we going to abstract for this future technology and as well as adapting with this AI, artificial intelligence or the nature intelligence. And then from hereafter, maybe 30 to 45 minutes, we are taking you how this agriculture began, where are we now, and what challenges we are facing, and how lessons from nature, nature-inspired solutions, and what they are going to guide. Agriculture is not just a food production, but there are farming technologies and as well as humanity. So, always nature, right? Nature simply always solve many of these problems, right? But different way, differently, we are struggling. And are we ready to learn from it? Or are we ready to go with this nature and identify their nature secrets or inspired solution and adapting current technology and moving forward? So if you're ready, so let us begin the journey. So what is agriculture? Normally we are thinking about tractors and as well as right now we have in Sri Lankan scenarios, most of the people they are thinking that is a field, fertilizer and some farmers. So it is bigger than that. Now, this is oldest tradition, oldest kind of profession in Sri Lankan scenarios. So you can see in your left hand side is anthropogenic disruption loop. So what we are doing, we are clearing the lands or the vegetations and the tillings, right, using different sort of technologies and all these things. And we are making the ecosystem shifting. So where we are increasing the light and reduce some competition, right? And then we are thinking about creation of human-dependent cutogens. So that is where the biological selection. So that is about agriculture, right? In your right-hand side, you can see three different crops where grass, like where these grains, right? That is Poaceae. Then that is where rice, so kind of grains there we are using as staple food. And then some Fabaceae, that is where some the nitrogen fixing and legumes and all these beans or some sort of soybean and all these things coming up. And third one is some the storage. So that is where root crop. So that is where the nature given to identify these three families. So those are disproportionate, and then that will definitely improve the agriculture. So that is where we are thinking about. So how we are going with these major agricultural stuff. So thinking about where does this began? So simply the archaeologist toolkit. So from these the organic matter, so sometimes dating organic matter, so then we are thinking about the pollen structures and as well as some silica bodies and then some starch grains. There are different, coming from years of millennia of years. You can think about their development. So simply Western region. So they are working with this, making some cultivation rye or the legumes. So they went with this plantation, right? Planting materials and all these things they are thinking. And then many ancestors, so they practically use this biomimicry. So they use that, nature solutions and all these things. When it comes to Eastern, so they use this livestock production. So that is where Western and Eastern get in together, and they have these, forest protected crop cultivation and animal domestication came together. So that is where, in simple terms, agriculture began when humans started learning from nature, observing patterns and working with ecosystems rather than against them. So that is where we have to think about, are we going with our natural ecosystem? So these are very famous diagrams. Those are cascade systems. So the Ellanga in Sinhala. So in our dry zone, very rich ancient history. So that is where we using this recycling, or the kind of cyclic circular agriculture started way back. Now it is very famous here. So cascade system, protection of the water sources and protection of these biosystems, biodiversity and everything. So that is where porous protected water sources, and then you can see tanks stored filtered water, canals distributing the naturally, and paddy field reuse nutrient recycling. So that is what sustainable system we had. So that is where we are really close with the nature. So that is how the ancient, our ancestors, right? So you know about our King Parakramabahu and those very famous coast there says. So that is where our Rajarata area done. So that is what we had in previously. And most of the people, or most of the youngsters now join with online here. So you can read the statistics, how important agriculture in Sri Lankan context. Most of the time, even the 42% of the 4 million, they are working in that field, and then some 82% in our rural area, and then total production around 92% unit for small land, that is less than 2 hectares, and economically 7 to 12% of GDP, and total imports 18 million USDs, and agricultural exports we are taking 2 billion. So you can see the economy joined with this agriculture. And again, more than right now ever before, we have to think about how we have to contribute in the country. So therefore, now the discussions going on, different digitalization of agriculture and improving the crop productivity, right? Production statistics, everything people are thinking. So therefore, again, we have to this is a social system simply. So in that economic engine we have, and foundation for national food security. So that is where significance of agriculture in Sri Lankan context, and you can see tea, rubber, cinnamon, coconut and everything. And what are the things we are importing? That is wheat, sugar. Some sugar we are producing in 10% less than in Sri Lankan context, lentils, oil palms and everything. So what kind of problems we are facing? So what kind of modern problems we are facing now? Climate change around the corner, heavy rains. We had the Jitwa cyclone as well, and then climate change impact and dengue disease burn coming up, and heat waves. We had heat island effect coming up, right? And extreme weather events, heavy droughts there, and ozone depletion, and not only Sri Lankan, most of these Asian context. A lot of floods are there, climate change, and it is changing the productivity, landscaping and everything, and endemic species coming up. So therefore agriculture facing very serious concerns, and extreme heat events, as I mentioned, floods, droughts, unpredictable rainfall, disease outbreaks, not only that, biodiversity losses, lot of things. So can conventional systems alone solve these problems? So we cannot, because it is changed. Now you can see initially your left hand corner, we have our land productivity, and we had the grasslands, porous cover, and right hand degradation. So it is happening, land desertification and the degradation, and then salinity, acidity, right? So therefore we have to think about, where are we now? These maps clearly explain that one. So what are the cases? Deforestation, soil erosion, and excessive chemical use, right? And then unsustainable farming and climate pressures also. So therefore, recycle now normal forest or normal ecosystems, or the agro ecosystem, they are recycling. When you think about a normal forest, recycling nutrients and protecting soils as well, and conserving water as the cascade systems, and maintain the diversity. So therefore, are we going to degrade this again? degrading the ecosystem or rescuing or using these nature-based solutions or redesign the agriculture using this biomimicry. And that is why exactly we are talking here biomimicry and the nature intelligence is most important and more powerful here. So what will the future be like? So now there are predictions, IPCC guidelines, and you can go and check it out, and Sendai framework, and as well as these SDGs and everything. You can think about what is happening, the projected temperature changes there by 2030, right? You can see these graphs. I don't want to explain. Most of these youngsters know really how these climate change mitigations, right? So we have done some, several researchers and some publications and kind of work out how this integration climate change adaptation into this microorganic farming, organic microfarming, and community resilience. So that is where future. So in that cases, so some showing this temperature, change in rainfall patterns, and some farming systems. We have to go with the smarter, and we have to go with this climate adaptation and then resilient urban food systems. Not only that, low emission agriculture. So we are thinking about, and what we do, what we have to focus on, we have to ecosystem health, we have to think about. We have to think about resource efficiency. That is what we are going to maximize the resource efficiency and the biodiversity, ecosystem services, and community resilience. Definitely we need. So this is where biomimicry more highly valuable. So where nature has already developed resilient systems over millions of years. Now, with this, inception of the world and how these systems recycling resources and minimizing the stresses and surviving the extreme conditions. And the future agriculture may not be purely artificial intelligence, right? So, but combination of artificial intelligence and the natural intelligence. So the farmers of the future must learn to think more like ecosystems. That is, we are talking from A levels, O levels about this ecosystem, system thinking, right? So this is the future. Now we mentioned we've been right now experiencing heavy rains as well, and drought we had experience. So therefore, that is where climate change impact in the global agriculture. Not definitely, right? Not only the normal climate. So when climate is happening, these extreme events and all these things, simply that will going to happen in this entire agriculture as well. So therefore, the future of agriculture may become more unstable, right? And if continue ignoring ecological balance. So definitely we have to think about the ecological balance as well. So therefore, images here, now you can see the images, now clearly see, right? Images, flood, droughts, right? Severe droughts, devastation, floods, climate disasters, displacement of communities, that is social pressure, and increasing pressure on the food systems. So that is where due to this climate change, right? Why? We change these natural systems, right? And we made more impermeable layers, degradation, land degradation, desertification. And climate change is not only an environmental issue. It is agricultural, economic, and humanitarian crisis as well. So that's why future agriculture must focus on resilience. We are talking about the resilience rather than only productivity or the profit maximization. So we need these systems should be adapt to the extreme weather, conserve water, and recover quickly after disasters. So, and work together with ecosystems. So that is why nature already does this remarkably well. So wetland absorbs floods. Now you think about the wetland, it absorbs the floods, and forests regulate the climate. Then diverse ecosystems recover faster after the disturbances as well. So therefore, future of agriculture must move from controlling the nature, so to collaborate with the nature. So, and that is where we are talking here, the biomimicry gives us that pathway. So think about the amazing or the natural intelligence, AI, artificial intelligence, way back 1950s, human intelligence exhibited by different kind of different machines. So that is this one shows this rapid evolution of AI. So 1950s artificial intelligence and 80s machine learning and deep learning in 2010. So machine learning simply learns from experience, similar to human. And the deep learning mimics the structure of the human brain, right? And then natural networks were inspired by biological neural systems. And that is why I highlighted amazing, A and I. So where, because agriculture today is entering into the era of artificial intelligence. Now we are maybe far behind. Now even we are not even the 4.0, right? But people are talking about the 5.0 as well. But the important message is artificial intelligence alone, it is not enough. So that is what we are talking about, this biomimicry, the nature inspired solutions as well. The future requires combine of AI with natural intelligence. That is the intelligence already existing in ecosystems, plants, insects, right, and animals and the natural processes as well. So nature is not outdated technology, but it is actually the world's oldest and most successful innovation laboratory. That is what our nature is, the most, oldest laboratory. So amazing or the natural agriculture, right? So where that? So that shows the something fascinating here. Now think about, plants are already intelligent systems. Why I am telling that? Because take a root, right? Root can sense the water, and it can detect nutrients as well and respond to the stress definitely, and optimize the plant paths, and even communicate chemically with surrounding organisms. So in many ways, this is really similar to modern AI systems. How? Sensing the data. So that is why we are sensors, and analyzing the conditions and the making decisions and continuously optimize the performance. That is what we are talking about. That is why we are getting, similar to the plant root as well. So right of this screen, that diagram shows the predictive control systems. So that is using the engineering and the AI. Interestingly, now you can witness that nature has been using similar feedback and optimization systems for million of years. Now this is million of years it is happening, and it's exactly what is that biomimicry teaches us. Now you can see these, down some drones and what is that, water systems as well. So they are posing artificial systems onto the nature. We can design technologies inspired by the nature intelligence. So what is that? Smart irrigation systems we are talking about, precision irrigation, right? And then agricultural robots or the robotic arms and different drones. Now there are a lot of drone sprayers, and then seed transplanters, and then precision farming tools. So they are mimicking the natural conditions. So that is what we are talking about, and they are sensing, natural sensing and adaptive behavior. Nature is not primitive. Nature is highly optimized technology. So that is what amazing agriculture we are talking about. And these are some lessons from prior ecosystem. So that is where how these prior ecosystem inspired. So that is simply sustainable agriculture, where deep-rooted plants inspired perennial crops. So they are minimizing this erosion as well, and natural soil cover and no-till farming. And they are using some, plant covers and mixed planting, sometimes polyculture, and sometimes rotational grazing. So therefore, this system is stability inspired by regenerative agriculture, and that is simply lessons from natural intelligence. So mimicking the agriculture, mimicking the natural systems. So deep-rooted systems here as well. And that is, nature has already tested sustainable systems for million of years, right? And then biomimicry means learning from those systems instead of consistently fighting against them. So what we are right now doing, fighting with the nature. But here we need to hand in hand going with collaboration with them. So that is where future of sustainable agriculture may already exist with the natural ecosystem. If we are not obey to the natural nature, so floods and hurricanes can be there. So these are some, research, resilience, and nature-based solutions we've been doing last, 2 decades or 15 years as well. So we developed some regression models for these inundations in some, flood prone areas, Alapatha, and some tank cascade system and disaster resilience, talking with, as I mentioned earlier, that one, and some hydrological modeling in these tropical river basins and some seawater intrusions. So a lot of activities we've been doing past, decades there. So flood prediction, soil erosion, climate resilience, tank cascade systems, seawater intrusion, and AI-based water management. So interestingly, many solutions again point back towards the nature. So that is what I want to mention, the biomimicry, right? Restoring ecosystems, as I mentioned earlier, right? And then improving watershed functions, using tank cascade systems, and strengthening resilience, and applying intelligent environmental management. So that is where advanced technology. Now you are doing the GIS, and then you are going with this hydrological modeling, and AI becoming more effective when combined with ecological engineering now, right? A lot of aspects there. And the future is not only about smart technology. So that is integration between technology and the nature. So that is what I want to mention about these slides as well. And this is one example in 26 flood and 27 drought. So government important in Sri Lankan context, more than 500,000 metric tons of rice, and a lot of, importation and paddy were destroyed, 150,000, and some, more than 130,000 hectares were left uncultivated during the Maha season, and we had a lot of crop failure. So therefore, we had to give some compensation to the farmers, right? Northern and North Central, and then these the Northwestern and all these things, and you can see these statistics. So where that there are reality, right? So definitely we need to take these resilient activities. We have to think about this is not agricultural problem simply. So this is simply economic and food security crisis, and a lot of lessons we have learned during that. Still we are suffering from that one. And here what we can say, climate action. So the climate, these problems are not a normal situation right here now. So they are not rare events. They are coming more frequently. So that is why future farming systems must become more resilient and adaptive, and then nature inspired rather than depending on conventional approaches. So that is what we have to take from these experiences. And very important here, lessons of nature. So these slides represent the core philosophy of the biomimicry. In your left side, read all the youngsters think about this one, right? Look in the world, how this philosophy of biomimicry, looking at the world through the lens of nature, right? Lens of nature. So you can see simply for the billion of years, nature has been continuously testing solutions through evolution. So what survives, right? What survives nature usually? Efficient, adaptive, resilient, resource conscious, and sustainability. So a diagram on the left explaining a biomimicry design process. So see scope and discovering and creating and the evaluating, right? Now initially what we can do is we can define. So simply we define the problem. Then what we ask how would nature solve this problem? So that is where we are thinking. Define the case and how nature, you go and check it out, how nature is solving. Next we can discover the nature modes and abstract the biological strategies, how nature solving these things, right? And integrate those lessons into human systems, and finally evaluate whether the solution is truly sustainable. So the larger wheel in your right hand side, so nature's operating principles. Now think about, they are adapting changing conditions, biologically attuned and responsive, and then integrating development with growth, and be resourceful with material and energy, and use life-friendly chemistry, and evolve to survive. So their example, right? Forest recycle nutrients, and wetland naturally filter the materials, water. Termite mounds, so that is temperature, they are controlling, and ecosystem remains stable through diversity and feedback loops. So therefore think about agriculture. Now we are thinking about the mess in agriculture. Modern agriculture definitely depends on often high external inputs, high excessive chemicals, resource extraction high, and linear production system, no recycling, no cyclic, right? Therefore, natural systems are very different. So therefore, now we have to think about recycle nutrients naturally, conserve water, and regulate pests biologically. So that is where the lens of nature. So therefore, nature is always something we can learn from. And perhaps the greatest innovation for the future of agriculture is not the inventing something completely new, right? So that is rediscovering how nature already works. So these are some lessons from the nature. So we have discussed last year as well. So we can see there are some Namibia desert beetle. So there are fog harvesting technologies there. So they have Sahara Project as well. And then you can see here Sahara Forest Project combines this solar energy and seawater cooling. A lot of activities going with to nature inspired solutions as well. And then designing systems functioning like a more ecosystems, right? So plant structures and filtration systems, you can see some down there, some plant structures, biological systems, and there are some natural landscapes regulating floods, and there are some filter systems, there are different plant roots, right? So therefore, we can build farming systems that are not only productive, also regenerative, resilient, and sustainable. So these are the nature very famous lessons we learn. And when it's come to this Czech Republic, that is the dump site to wetland, Parag, that is Czech Republic. So you can see they had a 56-hectare climate park. They convert that into, they had a flood problems, right? So they developed that into a blue-green infrastructure to manage the water or the restore the nature and connect the city with the river. So this is a very good example how they use this kind of nature inspired or nature based activities to develop this city into very nice climate park. And they use this bio waste dump site to a wetland, and still it is a very good example as well. And this is Hamlet waterfront residential development that is from the Vietnam. So what they have done is floodplain near the Saigon River. They divide by into very smaller segments, and they never going to change the natural system. They allow that one, and they develop into settlement. So this is one the world best very the famous settlement. And what they have done is they have used these wetlands naturally absorb the water, flood water, filter pollutants, and regulate the water flow, support biodiversity, and reduce climate impact. So therefore, their master plan secured the natural system. So that is where they never removed the wetlands. They preserved and integrated natural ecosystem. This is very famous one as well. So this is where the climate crisis and the smart agriculture. So this is in the Colombia. They had droughts and floods frequently. So they lost a lot of money and the lives and their resources as well. So here that the big data. Now we are talking about the data science, big data, right? So big data, they given alarms and then correct time as well. Then they can they can alleviate this vulnerable time period, and then they use that cracking patterns of big data, and that saves Colombian rice farming huge losses, and how technology and data analytics, right, help farmers respond to this climate risk as well. And this is where natural intelligence and the artificial intelligence can work together. So nature provides resilience always and ecological wisdom. AI provides the prediction and monitoring and rapid decision making. Future agriculture definitely will require this climate forecasting we need, and we need precision water management, early warning systems, and ecosystem restorations, and data-driven adaptation systems. So therefore, future farmers may not use only tractors and fertilizers, as I mentioned earlier, but they use satellites, sensors, AI models, nature-inspired systems working together as well. So this is where climate smart banana agriculture. This is Costa Rica, world third largest banana export. They're using the automated weather stations to identify, climate change, and they're using technology, climate science, and agriculture now working together. So Costa Rica, using banana plantation, is previously highly vulnerable for the floods, droughts, windstorms, and change in rainfall patterns. So to reduce that, they, as I mentioned, automated weather stations and online monitoring, mobile alerts, and agroclimatic bulletins. So therefore, they use, as I mentioned, artificial intelligence, environmental monitoring and modeling, nature intelligence. So these are very good examples. Modern technology helps to detect and interpret those signals more effectively. And future agriculture, as I mentioned, will increasingly use these partnerships between ecology, definitely ecology, ecosystems, data, and intelligent decision making as well. So now let's talk about what is bio-inspired AI. What is bio-inspired? So exactly that is combination of biology and computer sciences, right? So they are designing intelligent services and systems by learning from the nature, and modern AI techniques already come from the biological inspiration. So examples, now you can see the neural networks are inspired by the human brain. So we mentioned evolutionary algorithms, they are inspired by natural evolution. And swarm intelligence came from ants, bees, you know that. And adaptive systems imitate how living organisms respond to changing environment as well. And nature has spent billions of years optimizing survival, efficiency, communication, and adaptation. So bio-inspired AI tries to learn from those natural strategies as well. So biomimicry provide guidance through the nature-based thinking and ethics. So key idea here, combine technological intelligence with nature's wisdom for the better decision-making process as well. So we also need ecological wisdom, and we need ethical thinking, sustainability, resilience, and long-term balance here. So therefore, future is the integration of combining technologies here, and then we can get these nature wisdoms to better decisions for agriculture, ecosystems, and the society. So this is the natural intelligence here we are talking, natural evolutionary algorithms. So we are talking EA. And here initialization, selection, mutation, crossover, and termination. That is where the evolutionary algorithms. So this is system undergo mutation, crossover, selection, and continuous adaptation. So the stronger solutions survive and improve over time. Very similar to biological evolution. Now, you know the biological evolution. On the right side, you can see AI models used to biodegradability prediction here. So these systems help scientists, right? Scientists working on that one, how materials break down naturally in the environment, and future technologies must not only be efficient, but they should environmentally compatible. So key message here, what is the key message? Now, nature is not only inspiring AI structures, so that is they are guiding AI towards the sustainability, and they are inspired, encourages systems with adaptability, minimizing waste, right, and improve the efficiency and work within the ecological limits. So this is where natural intelligence becomes more meaningful than simply creating more powerful machines as well. So this is where we are thinking artificial neural networks, right, which were directly inspired by biological neural networks in the human brain. So these are immune systems and wireless sensors, right? So you can think about, with the time, I will not explain in deep. And why we need AI? So very simple, right? From 2017 to 2024, 7 years, you can see the precision farming we are thinking about, crop monitoring and management, automated irrigation system, precision irrigation, pest and disease early detection, right? And climate change adaptation, livestock management, robotic milking, right? Supply chain optimization, autonomous machinery. So you can use automation for the repetitive tasks, enhanced decision making, 24/7 daily availability, more and faster insight from data, fewer human errors, everything there. So this is what we have. We had a very very critical stage during 2018 to 2020, the Sena caterpillar. So we had a very huge crop loss as well, right? Cultivation in the Monaragala, that area. So so that is where we need to incorporate these natural artificial combined, right, intelligence to avoid this kind of situation. So that is where these days we can see there are a lot of softwares and some platforms there. So this is Plantix by Pete. So this is really important, where now you can get a kind of photograph and then here work in the natural networks, neural networks, deep learning, mobile AI, image recognitions, more than 400 plant disease and pest you can identify globally. So these are very famous how this technology using this nature-based identification and developing for these photos and giving to this one and identify systems and how this diagnosis and all these things happen. So these are very important. So therefore, you can see with these situations why world is moving about these kind of plant techs and other stuff. So here, next one is in India, fall armyworm. So occurrence, they identified more than 100K data points from Plantix. This is the Plantix I mentioned. They identified, they detect over 400 crop diseases and provides treatments, recommendations, supported multiple languages, right? That is really important. And global farmers. So therefore, Plantix demonstrates how AI can make agriculture smarter, faster, and more accessible. So this is again the crop defenses. So these are some activities our team working out about how artificial intelligence for early detection of blister blight, and again tea plant health monitoring and yield variability prediction. Valigama coconut. Recently, our one of our master's student conducted some researches, and banana fusarium wilt. Our some fellows working on it. So that is where the crop depends. So what AI and the drone technologies are transforming crop production through early disease detection and remote sensing, unmanned aerial vehicle monitoring and yield prediction. So these technologies definitely help farmers respond faster, reduce crop losses, and improve agricultural resilience as well. So these are some very famous and you can see and check it out, these lessons from nature. In agriculture, Russian olive tree, so they are developing. So this Russian olive tree contains natural alkaloid with antifungal, right? And antibacterial, and not only then antiviral properties. So I discussed this last year as well. So these compounds can protect crops such as rice, kiwi fruits, and citrus plants from diseases. Similarly, these natural defense mechanisms against fungal attacks, right? And then scientists studying these plant-inspired compounds develop some smart biofungicides and activate some pathogens and detection, right? So therefore, another fascinating example is this nematode pheromones here. So nematode pheromones, these are natural chemical signals used by organisms for communication. Researchers now using these pheromones for the biological pest control as well. And then we have the areca nut. So they have again, now we know we are using for the chewing beetles and other stuff. They have some different mechanisms for the antifungal. So these are plant-inspired antifungal compounds we can encapsulate into a liquid fungicide as well. So what we can do, studying this natural defense system or the biomimicking these things, say pesticides, neither. So we can remove these chemical pesticide as well, eco-friendly crop protection, sustainable farming methods, and smarter agricultural technologies. So these are the essence of biomimicry, and learn from the nature and rather than fighting against it. So and these are existing systems. So solar insect trap. So these are simply highlights this existing nature, learning from the nature, and some AI supported agriculture systems. So India ICAR, so they are using these things, right? And eco pesticide from tubers, that is Dioscorea hispida. So they develop those things, and some advanced machine learning approach for early detection. So those are the existing systems, right? Existing systems. These systems show how this biomimicry, renewable energy, AI, and precision agriculture can work together. That is where we have to amalgamate these different scenarios and how create the safer, smarter, and more sustainable farming systems as well. So this is what we had a big problem in 2021, total agrochemical import ban. You can see rice and the plantation sector, how this, our yield reduced. So therefore, there was a very debacle that organic or non-organic. So therefore, based on that, now we cannot go 100% organic. We at that time we had some seminars and all these things. We don't want to go for the 100% organic because we cannot go because these developed varieties, genetically modified stuff going with this, chemical fertilizer as well. Therefore, if we need for this organic or the synthetic, organic or synthetic, we have developed some inorganic thing for the years, right? Compost waste sludge and some alum sludge developing. So there were some problems, heavy metals and other stuff. Therefore, we can develop these things, organic or the synthetic. So we can think about both approaches both approaches have strengths and the weaknesses as well. So therefore, key lessons here. Future is not organic versus synthetic, right? Future. So that is about smart integration. So combining natural biological systems with engineered innovation and create sustainable, efficient, and climate resilient agriculture as well. And now all the people know about the circular. Right now we are going to linear economy, circular economy, no waste left behind. So therefore, that is the closed loop as well. So we are thinking about how to use these, compost in the agriculture, how we are using, recycling the nutrients. So therefore, these are some activities we have conducted during the past couple of years as well, and some sugarcane trash, and then AI-powered precise chemical application. Right now, we are working with these some multispectral cameras, thermal cameras, RGB cameras, and hyperspectral sensors as well. So a lot of activities, researchers combined with these some international partners. We are going with early detection or the thinking about pest or disease outbreaks, nutrient deficiencies, water stresses, uneven patterns. Here we can go onboard processors, or if not edge computing. So we can go give another area and analyze and capture, and we can use those things. A lot of activities going on. That is where AI-powered precise chemical applications we are working. So these systems definitely can identify pest and disease outbreaks, nutrient deficiencies. We are talking about the variable rates, spot applications, and all these things coming up with, AI applications. Definitely, you have to go hand in hand with this our nature systems as well. So this is where inspirations behind these drones. So flapping drones, right? You can think about getting some activities there. Spy drones, these days world, a lot of wars are going with the spy drones as well, right? And perching drones. Normally, when you are landing down, you have to have a flat surface. Now here you can see the perching now upcoming these things like birds and eagles. You can catch. You can land uneven surfaces as well. So all these things came the hummingbird. Now simply how these things mimic through the biomimicry or the nature creatures. So that is how inspiration behind the drones. So there are definitely you can get some drones there, right? So we started about in Ruhuna University, not only this Ruhuna and collaboration with other universities we are working, and currently we are trying with some China and India to work hand in hand with introducing these things to our farmers as well. And these are some high-tech AI-powered pollinators, right? So that is where AI and robotics are being used to support pollination in modern agriculture. So there are pollinators, pollinator populations like bees. Bees are declining these days. There are no bees at, sometimes due to climate change, pesticides, and habitat loss, we mention always. And researchers are developing AI-powered robotic pollinators inspired by the insects. So these are some examples. So the goal is not to replace the nature. So think about this is not the replacing the nature. So but to support food production, right? While natural pollination becomes insufficient, right? Then we are going for this artificial stuff. So another one is another example is how biomimicry and artificial intelligence combine to solve future agricultural challenges, right? That is what we are thinking. So what inspired the camera, right? Human eye, right? Movement-based camera. So that is where these things developed, right? What inspired camera. So there and scientist studies insect eyes sometimes, especially flies, butterflies, right? Insects has compound eyes made from thousands of tiny lenses, okay? And then giving them extremely wide vision, rapid motions, right? So therefore, biological systems inspired by movements-based cameras, surveillance systems, and advanced motion sensors. And some are from the butterflies. So therefore, as mentioned, human eye mimicked or the butterfly. So that is how these cameras done. And this is See and Spray AI system and USA. This is very highly mechanized and perfectly accuracy. So they are computer vision, deep learning and edge AI, robotics and CNN models, machine learning models there. So these machineries reducing 50% of this usage of herbicides, and they can save the millions of gallons of herbicides and more than 500 million acres. So these are some upcoming new technologies hands in hand with this AI as well. And this is the laser weed upcoming right now, right? This is accurate. You can see these diagrams, CNN models, robotics, computer visions, as I mentioned, autonomous systems as well. So eliminate weeds without chemicals. Now the big problem is the chemical. Right now we are having problems with this humus. What is that? Humus trait. So therefore now we can go with these laser weeders, that is develop elimination, and these are using with labor requirements as well, right? And precision irrigation, we are talking about precision irrigation, smart irrigation, digital irrigation. Here these drip irrigation systems. So therefore we developing now. World is moving with the reduction of this spot irrigation, right? Drip always 90% plus the efficiency. Therefore they are thinking about precise irrigation using the fig leaf and trying with and thinking about fostering different resilient stuff. And they are definitely we are thinking about precision irrigation, improve the crop productivity and the save water and reduce environmental stress, and as well as increase climate resilience in agriculture. And circularity. So this is where linear economy, right? You are eating and hit and run and no circular. So reuse. So that is why in Stocklock, the biggest cycling in, I think they collected during the cycling for 4.7 tons of used coffee grounds and different traditional systems, right? How these countries using different Scotland used Glasgow. We mentioned last time as well, coffee and community-based systems, right? They're London. They are using different sustainable system. Nature already works together with this, collecting these things and food waste, and sometimes nature already closing the loops, circular loops, and modern sustainability efforts. They are not now trying to follow the same logic. So these are the circular economy principle, and everywhere people are talking right now. And this is very simply think about the billion carbon. So this is very famous now in India.
The world is a waste crisis.
This is companies like the Billion Carbon.
Biodegradable waste.
They are using this short video.
We founded Billion Carbon,
2 minutes,
where we provide a complete food waste management solution. Food waste often goes untreated due to slow and costly treatment methods, emitting greenhouse gases. Now, India has mandated bulk waste generators to handle their wet waste internally. However, no viable solution exists. Billion Carbon was born out of a 7-year passion for climate action and 2 years R&D.
We provide a complete food waste management service for bulk waste generators, which is rapid, low cost, fully circular, and also contribute towards your ESG goals. Our innovation is a 3-day food waste treatment technology using our IoT-powered microclimate controlled bioreactors.
जिस वजह से हाउसकीपिंग रिलेटेड इश्यूज भी आता, इलेक्ट्रिकल कंजम्पशन, क्लिनिक ऑफ द यूनिट में फीडिंग करने के लिए जो किचन वेस्ट उसको कैसे से सेग्रीगेट करना एक चैलेंज था. Lot of smell, disease was there. Because of that, we were spreading all those kachra here and there. बहुत ही खुश है. They have recently working with this vegan carbon index. Power consumption almost zero हो गया. Safety measures जो है पहले से कम लेना पड़ता है.
काम करता 10 महीना जो उसे की विश्राम काम करी काम कराने है.
You guys, the waste is absolutely zero. So that is a very important aspect. And apart from that, I believe that the carbon footprint is also going to be reduced by all this.
We are on a mission to make food waste management faster, cleaner, and cheaper. Come join us to modernize your food waste treatment. We are Billion Carbon.
So that is where you can see that the nature-inspired technologies that can reduce the food waste and improve sustainability, right? So likewise, here we have developed some, wood apple, some gum and natural plant extracts. So that is where we can think about to use these to investigate sustainable surface coating. So we done taking some examples from the nature-based one and minimizing the waste. So globally, lots of fruits and vegetables are wasted after harvest due to the post-harvest, the spoilage. Therefore, natural edible coatings we can use from plant extracts and materials such as wood apple gum can help extend the shelf life as well. So these are smart platforms, right? These are smart platforms. So they are this crop smart platform combines the combining the machine learning, satellite analytics, predictive AI, big data, and 50 countries. So these are world largest AI platform for these people to work with more accurate and more sustainable decisions to improve productivity. And this is farm again. This is again a platform you can use to reduce the water waste and improve irrigation. That is where we are using this AI in agriculture in coming years. And this is very important. That is again combines sensors, predictive analysis, and mobile stuff. So that is where they are sensors accurately monitoring the moisture, pH, EC, temperature, and crop conditions. So while which AI makes instant decisions to optimize water and other activities as well. So what is the most important one is that is where advantages is the resource efficiency and reducing water waste, reducing the water resource, right? Reducing water waste, improving irrigation, smart farming technology. So this is again AI robo milking, right? That is where you get in that machine learning and sensors and 24/7 reduce labor dependency, early mastitis detection and everything coming up. So that is where people are working. AI is not replacing farmers. So don't misunderstanding. That is supporting smarter, more efficient, productive, and more sustainable livestock. And this is the robo arms we mentioned last time as well. Here, elephant, elephant trunks and octopus tentacles, right? So therefore, you can make some robo arms to grab those things. That is going with greenhouses as well. And here, definitely technology. Now we have the technology. Now normally you have to go to the site visits, check in, measure in, purchase in dealers, or order in logistics, poor repairs, a lot of things there. So how you can change using the technology, right? With the technology, you can eliminate most of these inefficiencies with AI, automation, smart sensors, online platforms, precision agriculture, right? Faster decisions and reduce waste, right? So beyond the technology, so we have to some systems should be in grounded. So we have to identify all these things. Technology alone not enough. So that is what first one. You will think technology can do everything, but technology alone cannot do things. So we have to have maintain the sustainable agriculture. There are climate smart practices, different farming systems, tea, rice, right? Mulching we need, rainwater harvesting we need, crop diversification we need, agroforestry we need, composting, and traditional varieties we need, right? So future agriculture, as I mentioned, not only about AI and machines. So it is about combining technology with ecological wisdom, farmer knowledge, sustainability, and climate climate resilience as well. So these are some activities in Sri Lankan context. So you can go and check how crop forecasting, Krushi Advisor, mobile map, and the beyond advanced machines, successful agricultural technologies we are using. And to do that, we need funding. So that is where we are thinking about how this funding are going up. Funding should be definitely a major barrier. So there are different organizations, right? So the youngsters or the researchers there. So you can think about there are ample sources to do that. And you can think about how to assess the funding, because the key message is opportunities already exist. Opportunities exist, but universities, startups, researchers, and farmers must learn how to connect ideas. So therefore, you need the collaboration, right? Collaboration, different foundations there, different countries there, and that is definitely needed. So therefore, the challenges we face, food security, climate change, water security, and sustainability, very big. So we cannot handle by myself or you alone. So we have to have the collaborations. So therefore, finally, I want to play this one, right? So very beyond intelligence. Now you have the intelligence. So listen this one. This is the last slide before that one. Listen this one.
Another UN official stated in 1989 that within a decade, entire nations could be wiped off the map by global warming. Not happening. You know, it used to be global cooling. If you look back years ago in the 1920s and the 1930s, they said, global cooling will kill the world. We have to do something. Then they said global warming will kill the world. But then it started getting cooler. So now they could just call it climate change, because that way they can't miss. It's climate change. Because if it goes higher or lower, whatever the hell happens, this climate change, it's the greatest con job ever perpetrated on the world, in my opinion. Climate change, no matter what happens, you're involved in that. No more global warming, no more global cooling. All of these predictions made by the United Nations and many others, often for bad reasons, were wrong. They were made by stupid people that have cost their countries fortunes and given those same countries no chance for success. If you don't get away from this green scam, your country is going to fail. And I'm really good at predicting things, you know. They actually said during the campaign, they had a hat, the best-selling hat. Trump was right about everything. And I don't say that in a braggadocious way, but it's true. I've been right about everything. And I'm telling you that if you don't get away from the green energy scam, your country is going to fail. And if you don't stop people that you've never seen before, that you have nothing in common with, your country is going to fail. I'm the president of the United States, but I worry about Europe. I love Europe. I love the people of Europe. And I hate to see it being devastated by energy and immigration. This double-tailed monster destroys everything in its wake, and they cannot let that happen any longer. You're doing it because you want to be nice. You want to be politically correct, and you're destroying your heritage. They must take control strongly and immediately of the unmitigated immigration disaster and the fake footprint. We must do so. Then he'd get in and he'd fly for all of that sacrifice and much more. Is to stop. Everything should stop. No more cows. We don't want cows anymore. I guess they want to kill all the cows. They want to do things that are just unbelievable. And you have it too. But you know, we have a border strong, and we have a shape, and that shape. And no matter what you're doing down here, the air up here,
So what I have to finally tell, right, that the wise person is willing to change, right, always, and adapt to the new realities. But today agriculture is facing climate change, resource scarcity, and technological disruption, and food security challenges. So this is our opportunity to youngsters here to rethink how we grow food, protect nature, biosystem, ecosystem resilience, and building sustainable systems. So future of Earth and the agriculture depends on the decisions we made today. So today we from from the word go from 7:30 maybe now 1 hour gone, more than that. So from 53 slides, we discuss about climate change and everything, but one slide, we listen about no climate change and everything. But wise man changes his mind, right? And fool never will. So this is our way of thinking. Therefore, now, as we mentioned from the very beginning, nature has already survived for billions of years because it adapts, recycles, cooperates, right, and balance itself. So if the humanity, we as a human, if we are ignoring that one, and no amount of intelligence or technology will protect us from climate change or food insecurity, water scarcity, and the environmental collapses. But I believe the youngsters here, generations to come, has the power to change the society. And we can build farmers that think intelligently, cities that waste less, and food systems that nourish both, right, people and the planet, and the technologies that work with nature instead of against it. So therefore, so do not just become graduates or researchers, engineers, policymakers, farmers. Become problem solvers every time, problem solvers, and become innovators, become guardians of the earth. Think about how to protect your nature, how to learn from the nature, how to use this nature inspired solutions as well. Because the future is not something we inherit, the future is something we create together. Thank you very much and have a nice evening. Good luck. Thank you all. Sorry for the delay.
Thank you very much, sir, for your insightful session. Now we can open for the Q&A session. We can give only one participant to chance for raising question. Now you can unmute yourself, and if you have any question, you can ask.
स्पीकर अनम्यूट करा लो. Of this 8:30 and 8:35 people are not in that much, wanted to ask questions, I think.
Yes, I think so. Then we
So
can.
if you want any questions, you can send me email or whatever. You can contact us. We will support.
Okay, so then we can wind up our today's session. Before the conclude today's session, so again we invite you to submit abstract. Tomorrow is the last day. And also this conference consists with interactive panel discussions and sessions. So again, we invite you to submit the abstract. And also, if you have missed any session in this webinar series, you can watch those through our YouTube channel. So again, thank you everyone for being a part of today's Nature Talk webinar series. So your interactive engagement and enthusiasm and thought-provoking questions made these sessions truly exciting and insightful. And again, I want to thank Professor Guttila Jayasinghe sir for sharing his valuable thoughts with us. And I want to thank you for accepting our invitation with your busy schedule. So, and your expertise has inspired us all, and we are grateful for the time and effort you dedicated to making these sessions so impactful. So together, let's continue drawing inspiration from the nature to drive innovation, sustainability, and positive change in our work and lives. Thank you again, and have a great evening.